All right, so now I'm going to do part C and D. So part C says to find v plus 2u minus 7w. So again, we are going to have our vector v here, 1, negative 2, plus 2 distributed out across vector u, which is 0, 4, minus 7 multiplied out over vector w, which is negative 5, 7. So then we get 1, negative 2 plus 0, 8 minus negative 35, 49. This is going to equal, then we're going to add our x components, so we get 1 plus 0 plus 35, and then negative 2 plus 8, and then here's our minus sign, so minus 49. And our resultant vector is 36, negative 43. So now in part D it says determine the scalar values a and b that make a times v plus b times u equal to the vector w. So we have our a here, and it's going to multiply out across v, and our b is going to multiply across vector u. When you add those together, they're going to give us our vector w. So then we're going to do a, and then a times negative 2 is negative 2a plus 0, 4b, and that's going to equal negative 5, 7. So we know then when we go and add these vectors together, this first component here is our x component, and that has to give us negative 5. And we know that our negative 2 plus our 4b is our y component, and that has to give us our y component of 7. So now we can turn this into a system of two equations with two unknowns, which means we can definitely solve it. So we have that a equals negative 5, and our negative 2 plus 4b equals 7. And this is pretty easy. We already know what our a is, so then we can just plug it in wherever we see an a in our second equation. And when we solve, we see that b equals negative 3/4. And then when we go to check it, we have our negative 5 in our place of a multiplied out across v plus negative 3/4 in our place of b multiplied across vector u. And when we do all of those computations, we get that sure enough, it's negative 5, 7. So it seems to work. All right, I think that's it.